to Easy Limo Learning Simplified. My name is Eric. I'll be taking you through this topic, squares and square roots. And for this lesson, we'll be looking at square roots of numbers by the method of prime factorization. So we will start by looking at the prime factorization method of finding the square roots of whole numbers. Then possibly our next lesson, we will look at decimal numbers. But for this lesson, we are going to focus on how to find the square roots of whole numbers by use of prime factorization method. So we have also some few sample questions to help us illustrate and see how that can be done. And then, of course, at the end of the lesson, we'll be able to give you some few questions in the form of assignment just to help you practice on the same as discussed during this lesson. So when we talk about prime factorization method, it's something that we've done before. You can check from our previous videos how we can be able to express numbers as a product of their prime factors in power form. So basically what you need to do is to first of all express the given numbers as a product of their prime factors in power form. Then you will be dividing the powers by 2. Remember previously when we were finding the squares of numbers using prime factorization method, we did the same thing. We expressed the numbers as a product of their prime factors in power form. Then we multiplied the powers by 2. So here now we are going to divide the powers by 2. Once you express the numbers as a product of their prime factors in power form, you are simply going to divide the powers by 2, as we are going to see shortly. So let's do it and see. So we have our first example here, the square root of 64. So we already talked about the symbol that is used for square root. You can see that symbol there, this one here. Every time you see that symbol, you know it means square root of a number. So how do you do it? So let's first of all express this number 64 as a product of its prime factors in power form. Then after that, we're going to divide the powers by 2. So let's see how that can be done. So in expressing this number 64 as a product of its prime factors in power form, one, you can use successive division or you can use a factor tree. Let me try and use a factor tree. So on the left hand side here, we write the prime factors of this number. But on this side, I'll be writing the result when this number is divided by the prime factor here. So 64 divided by 2 is 32. So you'll have to continue as long as this number is not prime. So you only cease to continue or you stop when you finally obtain a prime number on the right hand side of the branch. You know, there's the left hand side and there is the right hand side. So on the left hand side of every branch, we'll be using the prime factors. On the right hand side, we'll be writing the result of the division when this number here is divided by 2. For example, here we'll have to again divide this by 2. What is the result? 16 here. Again here, you'll have to divide this by 2 again. The result here is 8. So you see 8 here is still not prime, so I still have to continue. 2, 4, and finally 2, 2. So these are the prime factors, you see. So you simply multiply this. So what it means is that 64 can be written as a product of all these ones here, the ones that have cycled, you know, all these. So we have 2 by 2 by 2 by 2 by 2. How many 2s are there? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5. So by another 2 there. So there are 6. So that is going to be 2 power 6. So it means the square root of 64 should be equal to the square root of 2 power 6. So you simply divide the power by 2. You see, simply divide the power here by 2. So what do you get? That is going to be 2 power 3. So 2 power 3 means 3 is multiplied by itself twice, or I mean 2 here is multiplied by itself twice, or you can simply say there is multiplication of 2 here 3 times. So 2 by 2 by 2. So we multiply 2 by 2 once, by 2 twice. So what is, if you multiply the first 2, that is 4, and the other 2, the answer here is 8. So 2 power 3 equals to 8. So it means then the square root of 64 is 8. Remember, when you were talking about square roots, we said a square root of a number is a number that we need to square to arrive at that particular number. For example, if you're looking for square root of 64, we are asking ourselves, which number do we need to square to arrive at 64? So that is that number here is supposed to be 8. See, that number is 8. See, the number that we need to square is 8. And we said every positive number has two square roots, one being negative and the other being positive. So we can also talk of negative 8, you know. So in some other books, you might see like the square root of 64 is plus or minus root of 64. So there's supposed to be two of them. So I've only given one of them, the positive one. But take note that the square roots here are supposed to be 2. There are two numbers that when we square will arrive at 64. So we have another example here. So again, we'll just have to express the number as a product of its prime factors in power form first, then we divide by 2. So this is 441. So this number is not divisible by 2 because the last digit is not even. So it's divisible by 3 because the sum of the digits is 9, and 9 is divisible by 3. So here you can as well use the divisibility tests. We've done this before. You can check from our previous videos. We have done something on this. So 3 goes into 4 once, remainder 1. 14 4 times, remainder 2, 21, 7. This one is also divisible by 3 because the sum of the digits here is 12, and 12 is divisible by 3. So again, 3 goes there. 4 times equals of 12, and then 9. This one is not divisible by 3 now, but it's divisible by 7, so 7, 7. See? So that means then the square root of 441 is equals to square root of 3 by 3 by 7 by 7. You see? Which is going to be the square root of 3 power 2 by 7 power 2. So we have expressed the number 441 as a product with prime factors here, and then finally in power form. So that is going to be, we simply divide the powers here by 2 so that we have 3 power 1, 7 power 1. So 3 power 1 is just 3 and 7 power 1 is just 7. So the answer here is 21. See, the answer here is 21. So that is basically what you are supposed to do as you try to find the square roots of numbers using prime factorization method. Again, from the definition of a square root is simply a number that we need to square to arrive at a particular number. So which number do we square to arrive at 441? That is 21. So 21, you square it, you will arrive at 441. So there is another one here. You will do the same thing. So 17. So 1764. So again, this number is divisible by 2. 8, remainder 1, 8, 2. 2 again, 4, 4, 1. Now this is not divisible by 2, but 3. So 3 goes there, 1, 4, 7. 3 again, 4, 9, now 7, 7. So these are the prime factors. So you just multiply this. So it means the square root of 1764 should be equal to the square root of 2 by 2, 3 by 3, and 7 by 7. The product of all these ones here. See, 2 by 2, 3 by 3, and 7 by 7. So if you write that in index form, it would be 2 power 2, 3 power 2, and 7 power 2. So in finding the square root, you simply divide the powers by 2. So you end up with 2 power 1, 3 power 1, and 7 power 1. So 2 power 1 is just 2, 3 power 1 is 3, and 7 power 1 is 7. 7. So if you multiply the first two, you'll end up with 6, and then you multiply by 7. So this is going to give us 42. So it means the number that you need to square to arrive at this number here is 42. So 42 squared is equals to this. That is what we call the square root of a number. The square root of a number. So that is all how we are able to find the square roots of numbers. So we have few questions here to help you practice. Remember, the rule is you express the numbers as a product of their prime factors in power form, and then what do? You divide the powers by 2. That will help you arrive at the square root of a number. Again, remember what the square root of a number is. It's just the number that we need to square to arrive at these particular numbers. Yeah, so that's what we are trying to find. Which numbers do we need to square to arrive at this number? Which number do I square to arrive at 65, 65, 61? Which number do I square to arrive at 20, 25? And which number will I square to arrive at 9801? So you can always attempt. When you are done, you can always be posting the responses in the comment section. If you have any questions, still do the same. Just ask in the comment section. We look at them and give feedback as soon as possible. Otherwise, that marks the end of the session for this lesson. Until next time, goodbye.